Okay, so welcome to my video. It's going to be resolution of vectors through the analytical method. And so anyways, I've already drawn out my vectors and of course my nice little Cartesian plane. And I've also taken the liberty to go ahead and draw the components. Now the components are going to be basically um, these little sort of kind of like mini vectors that conform the vector as a whole. So of course we have our one that's lined up with the x-axis, which would be a sub x. To make it easier, we're just going to write it down here. And then we also have the one that's lined up with our y-axis, a sub y. Make it easier, we're going to put it right here. And so basically we're just going to solve for these different components. And then we're going to add them up. And then we're going to draw our resultant vector. And that's going to be our result. So anyways, let's start out. In this one, we're of course going to use sine. So it'd be sine of 20. Try to make that as neat as possible. Sine of 20 times our 17 newtons, because if we draw out the equation, that's what it's going to be. So if you plug that into your calculator, you're going to get that a sub y is equal to 5.81 newtons. 5.81 newtons. A sub y is equal to that. So we're also going to just put it right there so that we don't lose it. I'm going to go ahead and erase this, make that nice and neat. And then we're going to try and find a sub x this time. So using our SOHCAHTOA, opposite over hypotenuse is sine, which is what we just did, opposite over hypotenuse. And we're going to use cosine this time because so ka adjacent right here over our hypotenuse would give us a x. So it would be cos of 20 degrees times our 17 newtons would give us a sub x. And if you do some quick math on your calculator, you would get that a sub x is equal to 15.97 newtons. Of course, we're always going to write down our units, make sure that we don't mess up there. We don't want to forget a unit in our final answer. And that's what we have for our first vector. Its subcomponents, a sub y is equal to 5.81, and a sub x is equal to 15.97 newtons respectively. And now we're going to go with our force number 2, or B. Now we're going to go ahead and name these. Obviously B sub x, B sub x, nice. B, my bad, whoops. B sub y as well. So we're going to go ahead and try and solve for B sub y, which is of course using the same that we did with that one, sine of 20, parentheses, make it nice and neat, times this time 30 newtons, because that is what our hypotenuse is. And if we're using sine, it's obviously going to be opposite over hypotenuse. Convert that. You're going to get, if you type into your calculators, 10.26 newtons. Oh, but something that's really curious about this one, the reason I did 20 newtons and not 160 is because right now this one's pointing up, it's positive, it's going up on the y, so it's positive. But in the other one, we're going to see something interesting happen. 10.26 newton. Of course, what I'm going to do in the other one, you could definitely do in this one. Just for the sake of continuity, I'm doing it this way. So we're going to erase, or I'd rather just put it below our B sub y, 10.26 newtons. There we go, so that we don't forget that. Still keeping up with our units, of course. Now b sub x is going to be a little different. We're going to use the external angle because it's going to show us a result that I think you'll find interesting. So cosine, of course, like we did last time, because we're trying to find the adjacent, and we're going to do 160 this time. Why 160? Because we're going to do, like I said, the external angle, and 180 minus 20 gives you 160. Obviously, 30 newtons. And if you type that into your calculator, it's going to give you negative 28.19 newtons. And the reason this happens is really simple, actually. The angle that we're trying to find is not this, or that we're trying to find is not relative to the triangle, but relative to true zero, which is our x-axis. As you can see, an angle opens up this way, and it goes all the way over there. It doesn't just go this way. It's the other way around. But we have that b sub x. Actually, gonna draw a new b. That's really ugly. B, nice. B sub x is equal to negative 28.19 newtons. Simple enough right now. Go ahead and erase that, and then we're going to go to this angle right here, and like I said, going to go from true zero all the way down here. You're going to find that this is 270 degrees. And if we're trying to get technical about it, the one that always opens up would be solved with sine. So sine of 270 degrees is equal to, oh, my bad, times our 19 newtons. It would give us, yes, actually, negative 19 newtons. The reason this happens is obviously the arrow is pointing down below the x-axis, so it's going to be a negative value. So what it would be is c sub y is equal to negative 19 newtons. And then we're going to do the same thing, trying to find c sub x. Now c sub x we'd find using cosine, but you're going to see something interesting happen right about when you plug this in. So multiply that 19 newtons, and if you plug that in, it's going to give you 0 newtons. So c sub x is equal to 0 newtons. And this is because, of course, we have no movement going towards our x-axis or to our negative x-axis. So without any movement, there is no force, hence there are no newtons. So now that we have those values, you want to add them all up together. And then the sum of the x's will give you negative 12.22, and the sum of the y's will give you negative 2.93. So that's going to be important right about now because we're going to use those. Write it down, please. I'll give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds. Now we're going to clear all of this, and we're going to make ourselves a new Cartesian plane. You'll see why in just a minute. Now what we have to do is kind of make an estimate. What's really important here isn't the actual angle itself, but that you are keeping in touch with your units, and you're keeping in touch with your quantities and making all the correct moves. So this angle would be something right about here. Why? Because we go back around negative 12, we go down around negative 3, and that would give us our resultant vector, but we're not finished yet. We're going to make our dotted lines once more. So really quickly, it doesn't have to be perfect, like I said, what's more important, but that doesn't have to be perfect, but it doesn't have to be ugly either. My bad. So as you can see, a nice little right triangle right there. And so, of course, we're going to line it up with our quantities. So negative 12.22 and negative 2.93. Now I'm going to do something here. We're going to call this our R vector because it is our resultant vector, which we do not know. But this, of course, is our sub, this is Y, this is X, of course. This is R sub Y, and this is R sub X. Nice and simple. So we're going to find our hypotenuse. Of course, you got to do the Pythagorean theorem, which is a squared plus b squared equals c squared. You're going to plug these values in to get your hypotenuse. And it's actually going to be 12.56 newtons. This being because the negative symbols cancel out. And that's what you get. Now, if we're getting technical about it and you want to see what the actual answer is of a squared plus b squared, it's actually 157.9133 newtons. Because of course we're still doing newtons. So that's our first part of our answer. Now let's go for the second part, which is a little more difficult, but not impossible. So what we're going to do is that we're trying to find this angle right here, which we're going to call theta. Anyways, theta, if we're trying to find this, we're obviously going to use tangent, right? Because SOHCAHTOA, opposite over adjacent, right here. So it's going to look something like this. And you may think I'm wrong, but hold on 1 second. I'm going to show you something really cool. So tan of theta is equal to negative 12.22, which is our opposite, over negative 2.93. Now you're saying this is incorrect. Well, I'm going to show you a nice little trick. Tan to the negative 1, or inverse tan, cancels these out, leaves you with theta, because they're inverse operations. Theta is equal to that. So if you plug that into your calculators, this right here, it's going to give you a nice 193, no, my bad, 76.51 degrees. Because obviously what we're trying to find here is this little angle right here. Actually, if you type it in, negative 12.22 divide by negative 2.93, but we're actually going to not use that 2.93. And of course, you have to multiply as well, because that's the rule behind equations. You multiply that number by tan to the negative 1, or inverse tan. It's going to give you 76.51 2.51 degrees right here. But we're not done yet, because this angle is only relevant to us if it helps us find this angle relative to our natural zero, which if you subtract 76.51 from 270, because that's what that angle is, it's going to give you 193.49. So that means that our final answer is 12.56 newtons at 193.49 degrees. Make that a little neater. 49 degrees. And that, my friends, is our final answer. Thank you very much.